Well guys, let's prove that E lies between 2 and 3, assuming that you or we don't know the value of E and we also don't want to know. Well, I've written this assumption because, well, most of us at least know the first two digits of E, which is 2.7, 2.71828 and so on. And you can easily see that E lies between 2 and 3. And even if we did not know, we can easily put the expansion of E, which is E is equals to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on, and calculate the value of E from here, or also from definition of E, that limit thing. And we can also say E lies between 2 and 3 by calculating the value. So we don't want that. We just want a clear proof that E lies between 2 and 3. And first, let's prove that E is greater than 2, which is the easiest part of this. From here, you can see we have 1 plus 1, which is just 2. E is 2 plus, and then the remaining is 1 by 2 factorial plus 1 by 3 factorial and so on. So you have 2 plus some fractional values. So from here we can already see that E is greater than 2, or to put it in that form, 2 is smaller than E. So we first got E is greater than 2. Now, what about for E is less than 3? Now this is the part where it's the most difficult, but not to calculate, but just to think of the reason or the solution to find E is less than 3. So you're going to have to use the mathematical relation between factorial and power, which is that 2 to the power x minus 1 is less than x factorial when x is greater than 2. So x is greater than 2 means when x, let's say the least value, when x is 3, we'll have 2 to the power 3 minus 1, which is 2 square, 4, and we'll have 3 factorial, which is 6. So, and obviously 4 is less than 6, and you're going to have to use this relationship to find E is less than 3. And here we have E is equals to 1 plus 1 by, now 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on. So now we need that E is less than equals to some sum right here. We want a geometric sum to infinite terms, because there are infinite terms for the expansion of E, such that we can get a convergent value and say that E is less than 3, and that convergent value we want is 3. So from here we'll have 1 by 0 factorial, but we want 2 to the power something to replace these bottom factorials by using this relation, but obviously 2 to the power something can never be 0. So we'll have to put 1 aside and then focus on the remaining terms. 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on. So we want this series to somehow be 2 when replacing it with this relation. And here, let's begin. So right here we have 1 or 1 factorial, and we know 1 is just 2 to the power 0, and 2 to the power 0 is equals to 2 to the power 1 minus 1. And right here we have 2 to the power 1 minus 1, which is 2 to the power x minus 1. So this relation kind of doesn't work for when x equals to 1, because here you'll have 2 to the power 0 is less than 1 factorial, but 1 cannot be less than 1, so 1 is greater than or equals to 1. So let's not really focus on that, because here E will be equals to 1 by 2 to the power 1 minus 1, right? And similarly for 1 by 2 factorial, well, 2 is just 2 to the power 1, which is just 2 to the power 2 minus 1, and again 2 to the power 2 minus 1 is 2, and similarly 2 factorial is also 2, so in fact they're just equal. So they're just equal. That means this is equals to this. And from here, this is how we'll derive the relation. Now, let's come to 3. What about 3 factorial? Well, as I said earlier, x is greater than 2. So the least value we picked was 3. And we found out that here 4 was less than 6. So 3 factorial. 2, 3 minus 1. Right? When x is equals to 3, we'll have 2 to the power 2 less than 3 factorial. And similarly for 4, x is equals to 4, that means we'll have 2 to the power 4 minus 1, which is just 2 cube, and so on and so forth. So what we can do is just simply replace 3 factorial by 2 square, 4 factorial by 2 cube, and this equal to sign will change into a lesser than sign. Why? Because here we're replacing a fraction by a smaller fraction, so that means the value or this part will get smaller. Let's say you have 1 by 2 is equals to 1 by 2, and let's say that x is equals to 1 by 2, such that, well, yeah, x is equals to 1 by 2. Now that means x is equals to 0.5. Now what about if you replace 2 with 3? What is the relationship between x and 1 by 3? Well, 1 by 3 or it's just 0.333, and from here you know that 1 by 3 is less than 1 by 2. So that means this sign will be a greater sign, right? And over here what we're doing is just the opposite. We had, let's say, x equals to 1 by 5, and that means x will be lesser than 1 by 4, because here x is just 1 by 5, and 1 by 5 is less than 1 by 4, because here 5 is greater than 4. Thus, taking the reciprocal of these two fractions will also switch the sign of this greater than sign over here, or the equality sign. So that's something you can remember for future references. So over here we get e is less than 2 square plus 1 by 2 cube plus so on. And now we have our geometric series to infinite terms. So all we have to do is put the formula, which is that this sum will be equals to the first term, which is 1 by 2 to the power 0 is just 1 by 1, and the common ratio, which is just 1 by 2. So 1 minus 1 by 2. This is a very common geometric series to infinite terms. This is just equals to 2. You'll get 1 by 1 by 2, which is 2. So ultimately you'll get e is equals to is less than 1 plus 2, therefore e is less than 3. And from here you'll finally get that e lies between 2 and 3, and there we go, we have proved it, assuming we don't know the value of e and we don't want to. So the most important step is remembering this relation and just figuring out this equality over here. So a kind of a quick trick you can remember to know the equalities when we replace the value of something, I'll give you right over here. Let's say you have x equals to p by q. Now if you increase the value of p, let's just say p plus 1, then this relation will turn lesser than. So kind of the opposite. You increase the value of the numerator and then the x will be decreased. That means x will be lesser. And similarly, if you decrease the value of p, the x will get increased, right? X will be greater. Now for fractional values, this is the more easier one, I guess. If you increase the value of q, the x will also get increased. So that means they'll be the same kind of. You increase this will be greater, and you decrease this will be lesser. So that's the relation you can use over here. this is less than that, that means this will be less than this, right? Because here, let's say x equals to 1 by 2, increase that to 3, and x will be greater than 1 by 3. Decrease it to 1 by 1, x will also be lesser. So just a quick equality test you can do. So if you learned something new, please like and subscribe. Thank you.